Okay, so here we have a volume of 300 centimeters cubed, and we want to minimize the surface area. So either we're going to use a square-based prism or a cylinder. So let's try both of these and see which one is better. So for a square-based prism, to minimize the surface area, we're going to have to make a cube. So volume is equal to 300 centimeters cubed for a square-based prism, which is a cube. Volume will be the side length cubed. So it's going to be 300 is equal to s cubed, and so s will be the cubic root of 300. And so we get the side length of approximately 6.69 centimeters. And so now we can look for surface area. Surface area of a cube is 6s squared. So let's just plug that in there. And we get approximately 268.9, and this is going to be centimeters squared. So let's try the cylinder. So for a cylinder, to minimize the surface area, we want the height to equal 2 times the radius. So volume of a cylinder is pi r squared times height. So if volume here has to be 300, we can plug that in. Height has to be 2r, which we just said. So this means that we can simplify this side to be 2 pi r cubed, and r we can find by doing the cubic root of 300 divided by 2 pi. And we get the radius to be approximately 3.63 centimeters, and the height we know has to be double of the radius. So if we multiply that by 2, we get the height to be 7.26 approximately. So now we can find the surface area of the cylinder. The surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. So if we plug in our values, we get 3.63 squared, 3.63, and 7.26. And we get approximately 248.4, and this is in centimeters squared. So we can see that comparing the cylinder to the square-based prism, the cylinder is smaller. So the surface area of the cylinder is less than the surface area of the square-based prism.